So we are now moving on to graphing variations of quadratic equations, quadratic functions, parabolas. In the past, we've looked at quadratic functions that when you graph them are what we call symmetric around the y-axis. So they might look like this, or this, or maybe this. Right? Those are very poorly drawn, but the idea that those all have is that they are symmetric around the y-axis. They're the same over here on the left as they are on the right, right? Same thing, right? All of these, we say they reflect over the y-axis. So what we are now going to look at is what happens when we start to graph parabolas that might get shifted to the right or to the left, and how we're going to do that. Okay. So we're going to start with a reminder of how we graph a few very specific types of linear equations. So see if you can pull this out of your brain. If I ask you to graph the equation, the line for the equation y equals 5, can you remember what that line might look like? And remember, it is going to be a line. So pause and see if you can pull that out of your brain. Hopefully, what you came up with is that, well, on the x-axis, here's the number 5. And every point above and below that also has an x value of 5. So x equals 5 is a vertical line, straight up and down. That is the line for x equals 5. Similarly, if I asked you to graph the line x is equal to -2, you would graph a vertical line over here that crosses the x-axis at -2. Every point on that line has an x value of -2. Okay, so these are going to be important for us to remember how to do, because that's going to help us in graphing different types of parabolas. So let's look at example. So let's graph this quadratic function. F of x is equal to x squared plus 4x, x squared plus 4x. Now, the way that we are going to want to do this, and your instructions when you are working on these problems, is not just to graph the parabola, but find 5 very specific points. 5 points. And those points are the vertex, 2 points to the right of the vertex, and you can probably guess 2 points to the left of the vertex. To the left of the vertex. So, what's the vertex? What does that word mean? Well, in any parabola, whether it is going facing upward or whether it's facing downward, there's always going to be a point that is at the very bottom or at the very top. That is called the vertex. So what we need to do is find where that point is going to be. So that's going to be our first job when we're graphing any quadratic equation. Again, sometimes, I'm going to scroll back up, sometimes those vertices, which is the plural of vertex, are right on the y-axis, like all of these. But sometimes they're going to be shifted left and right. So what we have to do, the very first thing we have to do is step number 1. Before we can find our vertex, we have to find something called the line of symmetry. The line of symmetry. Okay, so here's how we do that. There's actually a formula, an equation that tells you how to find the line of symmetry. You're going to need to know this. It is x equals -b over 2a. negative b over 2a. What in the world does that mean? Well, let's go back to the original function that we're working with. F of x is equal to x squared plus 4x. You may remember that the standard form for any quadratic equation is y equals ax squared plus bx plus c. Quadratic functions, quadratic equations generally have three terms: an x squared, an x, and a constant term. They don't have to have all three terms. All they really need to be a quadratic equation is the x squared. That's the thing that makes them quadratic. But typically they do have three terms. And those three terms all have numbers associated with them. They have an a, b, and a c. The a and the b are going to be the coefficients. So a is the coefficient of x squared, b is the coefficient of x, and c is the constant. So in this equation that we are working with right now, what is in that a position? Well, what's the coefficient of x squared? It's the invisible 1. So we can say that for this function that we are working with now, a is equal to 1, and b is equal to 4. It's the coefficient of x. So those are the two numbers that we have to use over here in this axis or line of symmetry. So let's do this calculation. Negative b, in this case, would be negative 4. Here's our 4, over 2 times a is 1. So 2 times 1. A quick calculation leads to that being negative 4 over 2, which is negative 2. So what does that mean? It means that the line x equals negative 2 is our line of symmetry. That means that our parabola is going to be symmetrical around this line. And we just graphed that line a minute ago. It's this one, x equals negative 2. So that invisible line right there is going to be the center of our graph, the center of our parabola. Once we've done that, now we can go back to how we were graphing parabolas in the previous video, which was make an XY table. Now, in the previous video, we always started with 0 as our first value of x, and then went 1, 2, negative 1, and 2. We're not going to do that here. We have to start with our first value of x is that line of symmetry, negative 2. And then we are going to find 2 points to the right, which might be negative 1 and 0, and 2 points to the left, which might be negative 3 and negative 4. So again, here's the center, negative 2, and 2 points to the right, or two numbers bigger than negative 2, would be negative 1 and 0, and two numbers smaller would be negative 3 and negative 4. So what do we do with those? We plug those into our function. So f of, remember this is the one we're working with, f of x is equal to x squared plus 4x. I'm taking up a lot of room here. F of negative 2, negative 2 is from here, is equal to negative 2 squared plus 4 times negative 2, right? These take up a little bit of space. They take a little bit of work. Negative 2 quantity squared is positive 4 plus 4 times negative 2, which is negative 8. That's going to give us a negative 4. So this point right here, negative 2, negative 4, I'm going to scroll back up. Negative 2, negative 4 is right there. And the other thing we know about that point is that it is our vertex. It's always the point that's right on the line of symmetry. That's going to be the top or the bottom of our parabola, negative 2, negative 4. And then we keep going. So we'll do the same thing. We'll find f of negative 1. Here's our negative 1. It's negative 1 quantity squared, remember, because this is our function, plus 4 times negative 1. Well, that is going to be 1 plus negative 4, which is negative 3. So on my graph, negative 1, negative 3 is right here. And then we do one more. F of 0 is equal to 0 squared plus 4 times 0 is, oh, that just turns into a wonderful 0. All of that's going to equal 0. So there's our next point on the origin. So what you can see here is that this line is going to be going up. Here's the bottom of our graph, and it's going to be working its way up like this, right? And it's going to shape up like that. Well, because we already found the line of symmetry, we know that this left side is going to look exactly the same over here. But let's just confirm that by doing the calculations and finding what those other points would be. So -3 and -4. F of -3 is -3 squared plus 4 times -3. It's going to be 9 plus -12, and that is going to be -3, just like this one. And then the other one is f of -4, which is -4 squared plus 4 times -4, 16 plus -16. You got it. It's 0, same as here. So if we plot those 2 points on our graph, back up here, we have -3, -3. Notice how that's reflected right across that line of symmetry from the other point. And -4, 0. Our last point was -4, 0. So we'll put that right here. And again, it's reflected right across that line of symmetry. And we can finish off our graph. We can finish off our parabola. So there we go. That is what our parabolas look like. And we've seen those before. This one was now shifted a couple spots to the left from that y-axis. Okay, let's look at another one. Let's do y equals and let's go 2x squared plus 4x plus 1. So what I'm going to do is just say pause, see if you can follow the instructions from the previous question and figure out what this is going to look like. I'll keep going. So what is the first thing we have to do here? First thing we have to do is find the line of symmetry. We have to find where is the center of our graph going to be. How do we do that? With the equation x equals -b over 2a. Again, this is going to tell us where our vertical line is, where our up and down line is that represents the center of the graph. So what's our a and our b? A is 2, because that's the coefficient here, x squared, and b is 4. So our line of symmetry is going to be x equals -4 over 2 times 2. 2 times 2 is 4, so that's going to be -4 divided by 4, which is -1. X equals -1 is right here. So our line of symmetry is that x equals -1. So what do we do from there? Well, we set up our XY table, same thing as before. And our starting point is no longer 0, it's going to be -1. So we're going to work through these again. We're going to find -1 is our vertex first. Let's do that. Y is equal to 2. Make sure you put your number in parentheses, especially when you're going to square it. Want -1 quantity squared plus 4 times -1 plus 1. So this is +1 times 2 is 2, plus 4 times -1 is -4, plus 1. -2 plus 1 is -1. So there's our vertex, right? Remember, this is always going to be the vertex. -1, -1 is right here. And then we're going to do the same thing. But now remember, we have to find 2 points to the right of this and 2 points to the left. So 2 points to the right of -1 would be 0 and 1, 0 and 1. 2 points to the left would be -2 and -3. And then we will do these calculations. So y equals 2 times 0 squared plus 4 times 0 plus 1. 0 is always nice because it's going to end up making any term with an x in it just turn to 0. And all we're going to be left with is just that 1. So that's always a nice point. Where's the point 0, 1? It's right here. The next one is +1. Y equals 2 times 1 squared plus 4 times 1 plus 1. 1 squared is 1 times 2 is 2. 4 times 1 is 4. And then plus 1. 2 plus 4 plus 1 is 7. So we have the point 1, 7. So we can see what the right side of our graph looks like. Now let's do the left side. Y equals 2 times negative 2 squared. We're now using x as negative 2, plus 4 times negative 2, plus 1. Negative 2 squared is 4, times 2 is 8. 4 times negative 2 is plus negative 8, and then plus 1. This is 0, plus 1. Negative 2, 1 is right here, and yay, it's reflected right across that line of symmetry. And then we'll do one more. Y equals 2 times negative 3 squared, make sure to put that in parentheses, plus 4 times negative 3, plus 1. Negative 3 quantity squared is 9, times 2 is 18, plus 4 times negative 3 is negative 12, plus 1. This is 6, plus 1 is 7. And there's the point, negative 3, 7. And look at that. It makes a nice U shape. One thing you might notice about this one is that it is a little bit steeper than some of the other parabolas that we have worked with. Look at this compared to the previous one. Notice how that's a little wider at the base, right? This one's a little bit steeper. That's okay. Parabolas can do that. And those, the behavior of your parabolas, it's always going to be based on these numbers, the 2, the 4, and the 1, where they get shifted, how they're going to look. A couple other things to note. The parabolas we worked with in a previous video were centered around the x or the y-axis, and these ones are not. Can you tell why? I'll tell you why. What can you look at? Here's the generic form of a quadratic equation. If there is not a term for the x, if there's no b, if b is 0, essentially, if there's no x term, then it is going to be centered on the y-axis. Centered on y-axis. So your your equation might look like this. Y is equal to x squared plus 3, or y is equal to 4x squared, or y is equal to negative 3x squared plus 7. Notice how none of those have a b term. They don't have any terms that have just an x in them. They have an x squared. Some of them have a constant, but none of them have a b term. If that's the case, then you know it's going to be centered right on that y-axis. If they do have a b term, like y equals x squared plus 3x minus 12, there's a b term, then you have to find that line of symmetry. It's going to be shifted one way or the other. Or maybe it's y is equal to 4x squared minus 7x. It doesn't have a c term, but it does have a b term. So again, you're going to have to calculate where the center of that graph is. One other thing to note about these quadratic equations is that y equals ax squared plus bx plus c. Sometimes they open up and sometimes they open down. You know what the difference is and how you can tell by looking at the equation. It all has to do with either A, B, or C. Do you know which one? It's the A. If this is positive, then it's going to be opening up. If it's negative, then it's going to be opening down, like a frown. Okay? So that sort of explores some of our variations of quadratic equations, especially the ones that are not centered around the y-axis.